Okay, hello, Ellie, and anyone else who might need a recap. Okay, so circles. I'm going to run through this fairly quickly. You saw the video on how do we get the area of a circle, but before that, if we're given some sort of circle and there's the center, what is the name given to this line that goes from the center to the circumference of a circle? Well, we call that one the radius, r. And what happens if we went from the center to the circumference over here, say? Well, it's still the same distance, and that's what makes circles, well, one of the things that just makes them so amazing is if you're at the center, it's the same no matter where you look to the circumference, it's always the same distance r. Now, something else in our vocab maybe that would be useful is what happens if we took the radius and then went out to the other side as well? Well, that whole distance there then is the diameter, d. But mostly what we're going to be doing is working with the radius. So if you're given the diameter, you're going to have to divide it by 2. Okay, so let's look at our formulae. So we had the area of a circle. Well, that formula came out to be pi r squared. And that's going to be something that you're going to have to remember. You're not given it, you have to remember that formula. And we're about to use it. Okay, and then if you want to say find the circumference, which is just like the perimeter of the circle, then we use the formula 2 pi r. Yeah, let's run through an example, particularly to see how we keep this pi and deal with this idea of pi. So maybe just before we get to that, this number pi. Pi is just 3,1415,9, and it carries on forever and ever and ever. Now, where's my calculator just to double check that? Shift pi S to D 3,141592,654, blah blah. It really keeps on going. There's no way to write this as a fraction. So if you in junior school use this idea of pi is approximately equal to 22/7, that was just to make your calculations easier, and you can forget that idea for now until the rest of your life, because that's just an approximation. It's kind of close, but it's not what pi is. Pi is this long number, but it's around about 3 comma something. Okay, so let's take an example. If we have a circle with center here, and we're given that the radius of the circle is 4, and I'll ask you determine the area and circumference of the circle. So you happily go area equals pi r squared, and then all you need to do is substitute this radius. So pi is pi, and it's useful to write our whatever we're substituting in brackets. So radius is 4, so let's go pi 4 squared. Great stuff. What are we going to do first? This multiplication or the exponent? We're going to do the exponent because we always do bed mass, and I always do it like that, bed mass. So the exponent comes before multiplication. So 4 squared is 16. So it's pi times 16. It doesn't matter which order we write it, but it just looks and feels a bit better to write 16 pi. Remember when we wrote x times 16, we wrote that as 16x. We didn't write x 16. Although it doesn't matter which order you write it, this is the standard way. So the standard way is 16 pi. And that's it. Pi is 3 comma something. So 16 times 3 comma something. This is 50, say, this whole thing. But we leave the pi and we don't want to round off. And our units, well, we don't know what the units are. So we're just going to write U for units. And its area, we're going 4 units times 4 units. So units times units, units squared. Okay. And let's then run into the circumference. So circumference of our circle, you merrily go 2 pi r. And you go, okay, so 2 pi, let's substitute. What's the value of r? Oh yeah, I think it's 4, right? So 4, and we go, okay, well, if we're multiplying numbers, because this is 2 times pi times 4, let's multiply the 2 and the 4, because it doesn't matter what order you multiply. So 2 times 4 is 8, and instead of writing pi 8 pi, and our units, we'll just units. So if it was centimeters, it would be centimeters. If it's meters, it's meters. Okay, I hope that you're hitting pause and just hit rewind and rewatch that all again if you need to, because I know that I'm going through and I'm not leaving the pauses enough for you to really go through this, but rather pause now and rewind and rewatch the whole thing from the beginning before we go into our example if you need it. Okay, so here's our more full example. Determine the area and perimeter of the following compound shape comprising a rectangle and a semicircle. Okay, hit pause if you need to copy it down. Now, it says a rectangle and a semicircle. So it'll be useful, just like we did for our previous shapes, if we cut this into shapes that we know. So we're going to cut it, which I'm going to show with a dotted line. We're going to cut it into this rectangle. 1 is our rectangle and 2 is our semicircle. Rectangle, let's hit area first. Well, area of our rectangle, length times breadth. So 5 times 4 gives us 20. Now we've got some units, centimeters squared. Okay, for 2, we got a little bit more work to do. Now, if we wanted the area of a full circle, so let's actually just go through this a bit more slowly. I find it useful to sometimes just put a big dot where the middle of the circle would be. So now we can start seeing things like, oh, where's the radius? Well, this bit here would be the radius, right, from the center to the circumference. Now it seems a bit clearer that the diameter of our circle is the same as this side here, 4. And so the radius must be 2. 2, whether we drew it out that way, it's 2. Doesn't matter, radius is 2. So when we're looking at the area of the semicircle, the area of a full circle is pi r squared. So so for half a circle, it's just half of that. So now we just substitute the bits we needed. Pi, radius we said was 2 squared. So a full circle is pi r squared. Let's do that in another color here. So if we had a full circle, we'd have pi r squared. But we just got half a circle, so it's half pi r squared. And we get this and we say, okay, well, that's not too bad. 2 squared we're going to do first. That's 4, I think. 2 times 2, yeah, 4. 4 times a half of 4. I've got 4 Smarties. I want to cut them in half. Well, they're going to be 2 each. So we've got half times 2 squared. So 2 squared is 4. 4 times a half is 2. 2 pi centimeters squared. And so our full area of the whole thing is area equals both of these. Alright, so we need to take the first area and add the second area. So we got 20 plus 2 pi centimeters squared. We can't just go 22 pi because remember pi is about 3, we said 3 comma something. So this is 6 comma something, the second part. So what's 6 comma something plus 20? It must be 20 comma something. So we got 26 comma something, what am I saying? 26 comma something. And we can't say, if you're tempted to go, well, isn't that just the same as 22 pi? Look, 20 plus 2 is 20, 22 pi. But now pi is 3 comma something, 3 comma 1, 4, whatever it is. So 22 times 3 would be 66, 67. So clearly they're not the same. So we can't add those, just like you couldn't say 20 plus 2x is not equal to 22x. You can't just add them, they're different things. Okay, then for the perimeter, that's actually going to be useful, I think. Let's plonk down, I talked about saying, let's put down a little ant or tick on this side. Hello. And we're going to walk around. So our perimeter, let's walk around here. This side, what length is it? Well, that's 5, so this must be 5. So that's 5. Then we're going to keep walking around. Up we go. Well, that's 4. That's easy enough. Then we're going to walk along here. And we're going to be 5 plus, now life gets a bit more interesting. So for this last bit, let's do a nice light blue. For this bit round here, for this bit. Definitely going to be a bit more interesting because it's the circular path. Now, we know what the circumference of a full circle is, 2 pi r. But we want half a circle. So with the area, we just said we want half of it. With the circumference, we just want half of it. Okay, well that wasn't too bad. So this just equals a half times 2 pi. What is our radius? Well, it hasn't changed. And it's useful that we jotted it down in the diagram. So 2 pi times 2, which gives us, now we can multiply. So half times 2. Well, that's easy. Half of 2 is just 1. 1 times 2 is 2, so 2 pi. So therefore we know that this semicircular part is 2 pi. And we can just add this all together. So we've got our perimeters 5. Well, an easy way of adding these is 5 plus 5, that's 10. 10 plus 4 is 14. That is a bit easier than going 5 plus 4 is 9. 9 plus 5 is 14. No, not too bad. Plus this 2 pi centimeters. Perimeter, we're just walking around, no square units. We're just adding centimeters to centimeters to centimeters. So it's centimeters. And that's that. So when it comes to the questions that you need to do, you just need to break up your shapes. So for this one, break it into shapes, break it into a semicircle. This one's given to you. So I'm going to go semicircle and a triangle. Maybe it's useful to put that middle bit so you can remind yourself to get the radius, etc., etc. Have fun. Hopefully that's useful.